Alright guys, we are going to do some more projectile motion. We're going to do, I think we're going to do 4 through 7. 4, 5, yeah, 4, 5, 6, 7. Cool. So we're continuing on. It's going to be awesome. I got a camera this time. We're going fancy mode. I had to move this. I should have adjusted this, but now I'm doing it. Alright, so 100 aims directly at a target on the same level, 140 meters away. We're going to highlight some stuff because it's always good to highlight. So 140 meters away, I'm going to highlight that. And the bullet leaves the gun at a speed of 280 meters per second. Awesome. So they've already given us two things straight up. I'm going to leave the sketching to you guys, and we're going to go to B. Variables do you have? Make a chart like 1 through 3. So notice, like I was saying before, every problem they're going to give you less and less. They're pretty much going to not spoon feed you each one until they just straight up give you the question, and that's it. So let's do our variables. So first, we're going to write our formula. Displacement equals initial velocity times time plus 1/2 acceleration times time squared. Now we know that obviously it depends on which sides. There's going to be y and x. Alright, so initial velocity of x is going to be 280 meters per second. Meters per second. We know that this is velocity because meters per second is velocity, right? And that's your x. That's your like flat velocity. Our initial y velocity is 0. Our acceleration of x, unless they tell us, is 0. Our acceleration of y is gravity, so 9.8 meters per second squared. That's our units for acceleration, meters per second squared, right? Easy. Let's see, our time is, we don't know. I'm going to leave it blank. I do want to write it though. You got to write it. And our displacement of x and then our displacement of y. So our displacement of x, so away typically means the x-axis. So that's like our x, right? So 140 is our x, and our y we don't know because the bullet does drop, right? So you fire a bullet out of a gun, it's going to be dropping just as much as it's going to be, not the same rate, but you know, going forward, right? All right. So how long? So straight up the bat, looks like they want to know time. And how far, but this is the deal. Fall. So that tells us straight up. So how long, they're asking for time. And how far will it fall? So they're asking for displacement of y. Right? So that's easy. So we need time, we need displacement of y. I can sort of deduce right off the bat, because we know, like we said before, there's two sort of ways to do this displacement formula. We can do displacement of x or displacement of y. So displacement of x is initial x velocity times time plus 1/2 acceleration of x times time squared. Now if we do the y side, it's displacement, or excuse me, initial y velocity times time plus 1/2 acceleration of y times time squared. Now, looks the exact same, right? Obviously. The only difference is we know that in general, our x acceleration is going to be 0, and our y velocity, initial velocity, is going to be 0. So in this one, this whole side is going to be zeroed out, because if this is 0, then everything multiplying by that will be 0, right? So this side will be gone, whereas in the y side, this would be 0, which means everything on this side would be gone, right? So it's all set. So pretty much you're going to have to do one side and then you're going to have to do the other side. So they want to know how long will it take for the bullet to hit the target. So we got to find time. It looks like we have displacement of x, so I'm going to try this one first. The good thing is it's 50-50, so if you do the wrong way, no big deal, just do the other way. So I'm going to do displacement of x, always write your formula, equals initial x velocity times time. If you want to write this whole thing and then zero it out, that's fine. I'm going to skip over that because I know acceleration of x is 0, so it's going to be gone. All right, so displacement of x, now I fill stuff in. 140 equals, my initial x velocity is, uh-oh, did I just mess up? I think I started zoning out, actually. 280, there we go. I didn't write it. Did I not write that? No, it's there. It's there. Ooh. Don't multitask in your head. You will zone out. All right, so displacement of x equals initial x velocity times time. So far, so good. Now, this is easy algebra. Divide by 280, divided by 280. And we would get time equals 0.5 seconds. I'm going to box my answer so we can find it easy. So we can put this sucker right back up here because time, it doesn't matter which side of the formula, whatever, it's always the same, right? So we have our time. Awesome. So how far will it fall? So that's displacement of y. Easy. So displacement of y equals, I know my initial x velocity, or excuse me, my initial y velocity will be 0. So I'm just going to skip to the right side of the deal. 1/2 times 9.8, because that's essentially the acceleration of gravity, times time. Well, now we know time is 0.5, so 0.5 squared. So I'm going to break it into steps. So displacement of y equals, I know, but because I do this a million times, 1/2 times 9.8 is 4.9. And now we have 0.5 squared. So 4.9 times 0.5 squared, my displacement of y equals 1.2. And because it's displacement, it's going to be meters. I'm going to box my answer here. So that's pretty easy. Pretty easy, straightforward. Oh, I just did that off screen. Well, hopefully you got that. There we go. So 1/2 times 9.8 times 0.5 squared. That right there is going to be 4.9, and then bam, easy. So that one's done. So notice there was A, B, C, D on this one. So if we go to the next page, now all of a sudden they're just giving us A, B, C, right? So let's do it. Let's highlight some stuff first. A ball is thrown horizontally from a roof of 50 meters tall. So let's highlight 50 meters tall. So tall to me automatically tells me y. And lands 45 meters from the base. So again, when you see meters, you know it's displacement. So both of these are displacements. And when you see from the base, that means x-axis, right? So I'll let you guys do the sketch. I'm going to skip straight up to B. So variables do you have? So displacement of x equals 45 meters. Displacement of y equals 50 meters. You know it's displacement because it says meters. Acceleration of x is going to be 0 unless they give it to us. Acceleration of y is just gravity, 9.8. We're going to go meters per second squared. Let's see, they don't give us time, but we know it exists. So I'm just going to put t equals. And is that it? Displacement, acceleration, oh, initial velocity. We have initial x velocity. We don't know it, but it exists. And our initial y velocity is 0. Cool. So far so good. Easy money, right? All right, let's go to C. Remember, they gave us a lot less, so we're supposed to figure this out. So first off, we want to know the initial speed. Some people get confused and like, well, initial y or initial x? Well, we know initial y is 0, so it's got to be initial x, right? Or else, what? We just write a 0 and we move on. But they're telling us it's a two-part question, so we know it's not the initial y. So let's go ahead and do the displacement of y. If we do the wrong one, we just do the other one. No big deal. So we know that on the displacement of y, since my initial y velocity is 0, I'm going to just skip it and just say 1/2 acceleration of y times time squared. I'm doing less explaining in these because on 1 through 3 we explained a bit more. I hope. It's probably been a year since I did that video, so I'm just assuming. Oh, my camera's low. You can just see my head. We'll adjust that in future videos. Alright, so displacement of y. We know our displacement of y is 50 equals 1/2 times 9.8. We already have that memorized, hopefully, times time squared, and we don't know what that is yet. So 50 equals 4.9 times time squared. So at this point, let's divide that 4.9 over. Divide 4.9 over. So we have time. I'm going to flip it because I like my variables on the left. Just sort of FYI. I got to do this on my calculator. I don't know off the top of my head. So 50 divided by 4.9 is about 10.2. 10.2. But do we want time squared? No, we want time, right? So I'm going to square root this, and that'll turn that into just regular time. And then when I square root this side, 3.19 seconds. So that's my time. So I can go up here and put 3.19, and that's not our final answer because we want initial speed, which is our v. So let's finish it. So displacement of x equals initial x velocity times time. Other side's going to zero out, so I didn't even write that. So a displacement of x, which we know is 45, equals my initial x velocity. Well, that's what I'm trying to find, so obviously I don't have that. And my time I now know is 3.19. It's not squared because this is the left side of the formula, right? Not the right. So now we just divide it out. 3.19. Goodbye. 3.19. And our final answer is, so initial x velocity is 14.1. And because it's velocity, it is meters per second. Pretty easy stuff, right? You guys got this. Okay, so hopefully you've been pausing it and doing it and unpausing it just to make sure you don't get stuck. Let's do the next one. Okay, do they give us a lot here? I'm not doing the drawing, you guys do the drawing. Let's readjust. It's readjustment time. There we go. That's good. All right, a bullet is traveling 600 meters per second horizontally. A bullet traveling 600 meters per second. Why am I saying 600? It's 800. It's not 600. 800 meters per second horizontally hits a target 180 meters away. So I'm highlighting both of those. Now, I know that this is a velocity because it's meters per second, right? It's traveling at this meters per second, so that sounds like my initial x velocity is 800 meters per second. My initial y velocity I know is going to be 0. My displacement of x, so 180 meters away. So that tells me that is the x. So 180 meters. My initial, or my y displacement I don't know, but it exists. Time I don't know. And is that it? Displacement, initial velocity, time, acceleration. Acceleration of x is 0. Acceleration of y, as long as we're on Earth, is 9.8 meters per second squared. Cool. So I've got all my stuff. Easy money. How far does the bullet fall? So fall is y, right? So we want to know displacement of y. So another two-part question. If it's a two-part question, you know you're probably just going to do the x first, obviously, right? And they give us all this space, so that's kind of a giveaway too. So I'm going to skip straight to the x. So my displacement of x equals initial x velocity times time. As long as other stuff zeroes out, which it does in this case. My displacement of x is 180. They gave us that already. My initial x velocity is 800. And my time is I don't know, right? So we got to divide that 800 out. Easy algebra. Divide our 800 out, and I'm going to stall for time while I look at the key because I don't have it memorized, and our time is 0.225 seconds. 0.225 seconds, right? So I can go 0.225 seconds. Awesome. So now I'm going to go back to my y side. Displacement of y equals 1/2 times acceleration of y times time squared. Now I'm going to plug my stuff in. I don't have my displacement of y, so what we want to know, so that makes this easy, right? 1/2 times 9.8 times 0.225 squared. That's easy. So my displacement of y equals 4.9. And let's go ahead and do it out the full way this time. So we're going to go 0.225 squared equals 0.050. 0.050. I just rounded everything away. And then my final answer, displacement of y equals 0.2, and I'm going to round it up to 0.25. And then because it's displacement, what's the units for displacement? Meters. Bam. Cool. So that's it. That's pretty easy, right? All right. Let's go to the next one. Okay, solid 15-minute video, maybe a little longer. I'm kind of going fast though. Okay, so let's look at it. A student threw a ball horizontally out of a window at 8 meters above the ground. So you already know straight up it's a displacement because it's in meters. That's a displacement. That's in meters. Okay, now let's figure out which one's which. So when I think of above, I think if I'm looking up or somebody's looking down at me. So that sounds like Y. So I'm going to do my labeling stuff. I like to do X on top. So my Y is 8 meters. Another student who is 10 meters away. That tells me it's X, right? So that's going to be, displacement of X is going to be 10 meters. I don't know time, but it exists. Acceleration of X is 0. Acceleration of Y is 9.8 meters per second squared. My initial X velocity is, we don't know, but it exists. My initial Y velocity is 0. Cool. So, again, they give us a whole page. The whole page is blank, right? So, that's probably a 2-part question, which means whatever it's asking, we're probably going to have to do the other part first. So, I'm just going to straight up do the other part first and not get stuck or whatever, right? So, initial velocity. So, that tells me they wouldn't be asking for Y, so it's initial velocity, which is X initial velocity, right? So I'm just going to straight up do the Y first because it's a 2-part question. So displacement of Y equals 1/2 times acceleration of Y times time squared. Displacement of Y, oh, no, we had that. Okay. 8 equals 4.9. We're skipping some steps this time, times time squared. Divided by 4.9, divided by 4.9, so time squared equals, I'm going to do this on my handy calculator, 8 divided by 4.9, 1.63, 63, and then we got to square root it because we don't want time squared, right? So time equals, I'm on the wrong page again, silly me, 1.28. seconds. And then I'm going to box my answer so I can find it easy. Come back up here, 1.28 seconds. All right, now let's do the X, what we originally were trying to find. Displacement of X equals initial X velocity times time. Other side zeroed out. So my displacement of X is 10. My initial X velocity is what we're trying to find, so we don't know. And now I know my time is 1.28. Cool. So, if you would have done this, if you would have done the X side first, and then, you know, when people first start this unit, they get stuck because they're like, I don't have anything because they don't have time yet. And then they freak out and then they just shut down like physics is impossible, right? But you just got to chill, man. Like, just chill. You do one side, then the other side. Do what you got. So, let's divide by 1.28. Divide by 1.28. And our initial X velocity is 7.81, and then it's velocity, so it's meters per second. And then we're going to box our answer. Easy money. So, hopefully, you guys got it. Pretty easy stuff, I think. If you guys got any questions, let me know. Shoot me a comment. That's it.